Environmental conditions and shock. All right, guys, we're going to go through the concept for environmental conditions and how they affect the body and affect athletics, as well as how, therefore, shock plays a role and can be affected in the body at any time with any injury, environmentally related or not. So, remember, our whole goal in the body is to maintain homeostasis. With that in mind, depending on the environment, our homeostasis can be changed. If it's too hot, we get hot, therefore our body needs to figure out a way to cool us down. If it's cold, we get too cold and our body needs to figure out a way to heat up. So this is a factor, especially when it's damp or windy. It has more of an effect on us as and our bodies and how we maintain everything versus a dry condition. These conditions create health problems for athletes because when an athlete is out in an environment that is not exactly what we want, meaning it's on two ends of the spectrum, either too hot or too cold, their body's going to have to work double time, not only to do the actual activity that they're trying to do, but also to then therefore keep their body at homeostasis with the additional environmental constraints put on them. To maintain homeostasis, which is our whole goal and is to be in the best way possible to keep this, is to keep the body well fed, well hydrated, well rested, and physically conditioned. This way it keeps it regulated and is able to function properly. So, like I said, remember our body wants to maintain homeostasis. To maintain homeostasis, we have to keep the control of our temperature. And remember, the control is through the the hypothalamus within the brain. So these nerve impulses are sent to the hypothalamus to control body temperature, meaning if the body temperature has fallen below normal and or has risen above normal, it's going to be affected. Also, the hypothalamus tracks this. So the body cools itself in a variety of ways, 80% of which is through the skin for heat loss. So the heat loss is 80% through the skin. So that's the major way we are allowed, our bodies allow heat loss. Sometimes we need to have more heat loss if we're too hot, or sometimes we're trying to prevent heat loss if it's too cold. So if it's too cold, our body gets signaled to do other things, i.e., shivering. So when we shiver, it's our muscles are contracting. And when our muscles contract, it's a reaction, a chemical activity that burns calories and creates heat. To maintain homeostasis, we create heat or chemical reactions throughout the body. So that's how we increase our heat is we shiver potentially, or we contract muscles, or we're converting food to energy. All those chemical reactions create heat. And then if we want to cool, there's a couple different ways that we can cool or have heat loss, which is convection, radiation, or evaporation. Convection is the layer of heated air next to the body. If it's constantly moving, that's how we eliminate heat loss. We heat that air up and it moves away. We heat that air up, it moves away. Think of why we use a fan and why a fan cools us off. It's blowing different air on us. Radiation release of rays in different directions from a common point. So this is a transfer or loss of heat from a source surrounding an environment like heat waves or rays. Evaporation is liquid vaporizing from perspiration off our body. When it evaporates, it takes the heat with us and away from us. So exertion leads to perspiration, i.e., sweat. So perspiration or sweat depletes the body of water, and so does urination. But if this is why when it's incredibly hot out or you're sweating a lot, you want to maintain your hydration levels and continue to hydrate. We always want to make sure that we're being hydrated, especially when there's vomiting or diarrhea or fever. You don't necessarily need exertion to become dehydrated. If you are ill, you can be dehydrated as well. So the rate at which perspiration evaporates is strongly influenced by humidity. So as we've seen, if it's humid out, we sweat, but we stay sticky, like we don't dry. So therefore, we're less likely to have that evaporation. So therefore, we don't release the heat as well. When it's a dry heat, think of like an Arizona heat or like heat of an oven, we dry very quickly. So we sweat and we almost don't feel the sweat, or our shirt dries very quickly. Therefore, we're evaporating and we're losing heat a lot. But because of that, you can become dehydrated very easily and not know it because you don't realize that you're sweaty. So we want to take those all into factors when we're trying to deal with environmental heat stress. So when I say humidity, that's the amount of moisture that's in the air. When we do measure heat, we have to measure the heat and the temperature as well as the humidity. Relative humidity is calculated by the amount of vapor in the air, water vapor in the air, um, and the amount of air that could contain the same temperature. We use these two things combined to call what's called the heat index. The heat index is what it really feels like. So the higher humidity, if it's a high humidity and a high heat, we're at a much higher heat index versus if it's at a high heat with a low humidity level. So if it's at a high humidity level, we're much more likely to see people that can't cool down as well, and we're at much higher risk of any heat illness or heat stress to the body. When humidity exceeds 70%, players need to be incredibly closely monitored. For example, if it's 80 degrees out with 70 degrees humidity, people don't think it's that hot. But if it's 90 degrees out with 30% humidity, people complain of the heat. So people don't notice it as much as one problem. And also, we're unable to cool the body as well when we have higher humidity. So when we talk about relative humidity and temperature and heat index, these are the charts that we use. So we come up with a number. So if it's 96 degrees outside, but then 60% humidity, then it really feels like 116. So it significantly changes things compared to if we were just looking at the heat temperature wise. When you measure this, there's all different tools. You use a psychometer to measure relative humidity, and a lot of them will do the heat index temperature conversions for you. And they also measure the temperature while they're out there. There's also called the sling psychometer, which is one that you literally sling around and measures the humidity in the air as well. So these are some examples for training guidelines. So if there's low humidity, but it's 80 to 90 degrees, you want to carefully observe and watch, and those with special weight considerations or any issues you want to pay attention to. But if it's greater than 70%, then you need to make sure that they're resting properly and drinking water every 10 minutes on the hour, and a lot of water. So you just have to pay attention. And if it's over 100, over with 70% humidity, I mean, we're talking about potentially canceling or changing what we're doing. So sunburn. Most people don't think of much when you think of a sunburn, but it is a form of heat illness. It's a potential hazard for anyone that participates outside. We know this. We've all been around. Most of us know we should wear sunscreen. Some of us do, some of us don't. Um, but it can cause skin cancer and premature aging, and also severe burns can cause swollen skin, blisters, fevers, chills, and headaches, and it can lead to more dehydration. However, most symptoms aren't that severe, and any symptom decreases within 72 to 96 hours. Sometimes medications can cause people to burn very easily. And sunburns, as most of you know, are very painful. So you can also be sunburned in the snow. We want to make sure people take that in consideration. People kind of forget that because when you're not at the beach or the pool. When you have a sunburn, immediate treatment, you want to use aloe for moderate burns. And if potentially it's worse, more severe, then you might need to go see a doctor. But follow-up treatment, you want to make sure that there's no type of infection or blood poisoning due to sunburn. You can have dehydration related to this, and you can have what's called sun poisoning, where you feel ill afterwards as well. Prevention, we all know these. Wear sunscreen, wear proper clothing, use sunglasses. When you want to use sunscreen that's over 15 SPF, remember we want to make sure that we are properly protected. So heat illness is preventable. That is the biggest takeaway from this. Heat illness is preventable. It's one thing that we can prevent in sports. A lot of things we can't, but heat illness we can if we're treated properly and we're prepared for it. It's basically the accumulation of body heat, and we can't cool ourselves. So we can't maintain that homeostasis. So, possible causes of heat illness: inadequate heat acclimatization. So if you're not used to the heat, that can cause you to have heat illness. Inadequate fitness level, having a higher body fat levels, dehydration, illnesses or fever, salt deficiency or gastrointestinal distress, or inadequate meals can all be factors to cause heat illness. You want to make sure that they're also sometimes overly motivated athletes can give themselves heat illness, any other type of medication, or those that are reluctant to report problems, or those that aren't eating. Those are all things that can cause heat illness and make it a bigger problem. So, the most minor of heat illness is heat cramps or muscle cramps. So most people have had these, but they're painful spasms of your muscle. Traditionally, or most commonly, it's in your calf. It's most likely caused by a lack of volume of liquid, so dehydration. So you can prevent them by drinking the proper amount of fluid. So you want to make sure that people are drinking properly prior to exercise, as well as after and during. And when athletes are controlling their own fluid, most likely they're not going to overhydrate. It's very, very rare. Most athletes drink as much water as they would like to during practice and not schedule it. So they'll learn how to replace their fluid and what makes them feel well. You always want to make sure that there is an unlimited supply of cool water. It doesn't necessarily have to be cold, but cooler water. You don't want hot water. And each athlete should have a separate bottle for this. Even before COVID, you don't want to spread any type of disease. Heat exhaustion is the next level of heat illness, and it's a physical reaction to the heat exposure resulting from dehydration. So this is most oftenly shown by profuse sweating and extreme weakness or fatigue. And the thing is, heat exhaustion can quickly escalate to heat stroke if it's not caught quickly enough. So we need to pay attention and beware of this. If someone had extreme sweating, we're not talking just a regular sweaty athlete, extreme sweating or extreme weakness and fatigue and or changes that can quickly escalate to heat stroke. Heat stroke is when the inside body temperature is elevated so much so that the internal organs begin to shut down because of the heat. In essence, as terrible as it sounds, you're literally cooking from the inside out. This is a medical emergency, and you need to treat it as such, and it can cause permanent brain damage and or death. This can occur suddenly, or it can start, with heat cramps or heat exhaustion and escalate. It can escalate slowly or it can escalate quickly. It just depends on the situation. The difference between heat stroke and heat stroke and heat exhaustion is traditionally heat stroke, you have now stopped sweating and you have flushed skin, meaning you're kind of pale, where heat exhaustion, you have bright red skin and you're sweaty. Those are the big differences. However, the true definition of heat stroke is having a body core temperature as over 104, 102 to 104. So that's where we're talking about how we're literally cooking from the inside out. So here is kind of a chart to basically reiterate all of that. Now, once you get that one of these, if you have muscle cramps or have heat exhaustion or have heat stroke, depending on what it is how are you going to treat it? What are you going to do about it? So with heat cramps, traditionally it's more hydration, replace sodium losses, stretching, massage, and once the signs and symptoms are gone and you're able to move, the athlete can return. Heat exhaustion, you need them to rest in a shaded area, cool the body down, put the ice on the neck, armpits, groin area, have them rehydrate in small quantities, remove excessive clothing. However, if they do not improve, you need to activate EMS and send them by EMS because you want to make sure that they're not developing heat stroke. And therefore, Because of all of this, they should not resume exercises until rested for at least a day to 24 hours, and a lot of times medical clearance prior to being cleared again for participation. Heat stroke, like I said, is a medical emergency. They need to go to the hospital. They need to be cooled properly, completely, with traditionally with ice immersion or any ice packs or wet towels. And the athlete needs to be completely asymptomatic and cleared by medical prior to them returning to sports. So, how do we prevent this? So, one way to prevent heat related disorders is recording athletes' weight before and after practices. Weight loss in excess of 3% of body weight from sweating needs to be noted and also potentially needs to be replaced prior to the following day's activities. Observe for heat exhaustion those that are losing too much weight, and a loss of more than 7% needs it, they need to see a physician prior to participation. So another way to prevent it is checking the body fat percentages for different athletes, and those with low body fat percentage are more likely to experience heat cramps because of their body metabolism. And also, you want to make sure that you're checking the weather forecast constantly before and during competition, measuring the temperature outside, knowing the forecast, knowing the weather that's happening, having your own monitoring system, and having an EAP ready. If you have your EAP ready, you should be ready to go with any type of emergency. So, with all that in mind, you also need to be aware of the duration and intensity of practices if it's hot and humid, and you need to be able to use acclimatization strategies to make sure that these athletes are ready for this workout. So, to do that, it can take up to 2 weeks to acclimatize to the proper levels. So, it's a slow process. It's just like, in essence, quote unquote, getting into shape. But if you're not used to the heat, even if you're in very good shape and then you go travel from Southern California where it's 80 degrees to Arizona where it's 115, you're not going to be climatized to that temperature. So it takes anywhere between 10 to 14 days slowly to increase and get used to those climate changes and therefore not be at high risk of heat illness. You want to make sure that you're selecting the correct clothing. You want to make sure that it either is a fabric that can be light or lightweight or vented if it's hot, or black or dark colored if you're trying to keep the heat in if it's cold. And you want to make sure that sweat-soaked shirts are removed and changed. Um, Athletes should also avoid caffeine, alcohol, or carbonated beverages because those are dehydrating factors. So remember, we're trying to stay hydrated. So for every pound that's lost, the athletes need to replenish with 20 ounces of fluid. So every pound, 20 ounces of fluid needs to be replaced. Thirst isn't an adequate indicator for water needs during exercise. If you're thirsty, most likely you're already 2% dehydrated. So you need to make sure that you always have water available and encourage and have people drinking it and almost not necessarily forcing it upon them, but reminding them that they need to drink water. Now, we want to also make sure that they're drinking before exercise. So, kind of a rule of thumb is 2 to 3 hours. You want to make sure you at least drink 17 to 20 ounces of water, and 10 to 20 minutes before, you want to make sure you had another 7 to 10 ounces. So, that's a smaller water bottle type size. During exercise, you want to make sure that every 10 to 15 minutes, they're drinking about 7 to 10 ounces, and you want to make sure to have the water continuously available. They want to make sure the water's from cool fluids empty faster from the stomach than warm fluids. So that's why you don't necessarily want warm water because no one wants to drink that. But if it's cool water, they need to continuously drink because they will empty it faster. Athletes also need to monitor the color and volume of their urine. You want the urine to be a light color yellow or very, very pale yellow. Dark yellow or one with strong odor means that they are dehydrated. Vitamins can also change the color and odor of urine. So if it's something strange or an athlete says something, you may want to ask them, do they take any vitamins that day, or do they always take up vitamins? However, but you want them to have clear or light colored urine. I ask my athletes all the time what color their pee is, especially when we're dealing with heat illness. And at first they'll look at me funny, but then they realize that that's how you can tell if you're hydrated or not. If you're peeing more regularly with a light color, you're more hydrated than if you're peeing less often and very dark colored urine. An athlete with a fever is more susceptible to heat problems. Obviously, you're already at a higher body temperature and you're already fighting off most likely an infection. That's why you have a fever. So that's why you're at more risk for having heat problems. Fluids that athletes drink should always be available during practices and competitions. And some people prefer sports drinks over water. However, you do want to have some sports drinks available, but they don't want to exclusively drink sports drinks. There's a lot of sugar involved in sports drinks and other things, but they do have sodium and potassium and chloride in them. So you do need to have them, but not exclusively. You need to have a combination of water and sports drinks. Salt can be added to water or sports drinks to help with hydration and to help with prevent heat illnesses. So you want to make sure that they have a well-balanced diet to prevent this as well, and also avoid any energy drinks or caffeine, as I previously mentioned, because normally our diet has enough salt in it. We don't necessarily need to add it unless they have a history of heat cramps or you've experienced it and you're trying to negate it or mitigate any type of symptom. So cold. So remember, we talked about wind and moisture complicates everything. It's the same on the cold side. So moisture limits body's ability to conserve heat as well as to expel heat. So it's one of those things where moisture, if it's wet, that's why, if you have a wet t-shirt, you get colder faster. Wind chill factor. That's why they even have that measurement. It's how the wind changes the temperature and how it can be a real feel versus the actual temperature. Velocity of the wind cools the air. Just like the convection we were talking about, the way to heat loss. If the air is constantly moving, it's taking the heat with it from everything, so it makes you colder quicker. So precautions need to be taken when you're participating in cold weather sports, just like they are with hot weather. Fortunately, in our environment, we don't deal with this pretty much ever, but you need to be aware of it. When an athlete stops moving and remains exposed to the cold with perspiration, so like if they've been running around and they get sweaty and now their shirt's a little bit damp, the body's going to have a significantly hard time maintaining the heat because they're going to lose heat very quickly because they're damp and in a cold environment. So this is why a lot of times you need multiple layers as well as potentially changing your layers. Hypothermia is what we call when it's unusually low body temps. This can cause cardiac arrest or problems with the central nervous system. This is when the body's core temperature drops below 95 degrees. Death can occur in hypothermia if it's not properly treated. Symptoms are shivering or slurred speech or confusion, loss of memory. Severe cases, the shivering actually stops and muscles become rigid and contracted. The skin begins to turn blue. So that's, you've always might have seen the shows where someone's trying to potentially freezing to death. That's what's happening. Immediate treatment, you want to remove any and all wet clothing and replace it with dry clothing. Move them to a warmer environment. Add heat packs to their armpits, neck, and groin. Notice armpits, neck, and groin. For heat, we added ice to those areas. For cold, we added heat to those areas. Those are core areas that can help change the body temperatures the quickest. You want to put blankets over and beneath them. And if symptoms don't improve, you need to contact EMS and also monitor vital signs. Follow-up treatment, you need to follow any type of doctor order and also make sure that there's no signs of neurological impairment. Prevention, keep athletes warm and dry, wear hats and gloves, proper clothing, and you need to monitor the wind chill factor. Frostbite. So frostbite is not the same as hypothermia. Frostbite is actually the freezing of the skin and tissues that reduced blood flow. This can be potentially permanent damage to areas and or loss of limb or loss of fingertips. Frost nip is the term for mild cases. It's less damaging. Skin becomes cold and pale and waxy. Symptoms range from aching to tingling to numbness to where the skin actually turns white or gray and gets hard. Um, Treatment, you need to contact EMS if you see this happening. You want to remove any jewelry if possible. And you want to slowly warm the areas with blankets or body heats. You don't want to rub it, and you also don't want to move too fast. Now, in severe cases, sometimes you will need to do rapid rewarming, but also this is where EMS comes into play as well. Follow-up treatments, you want to follow MD orders, and prevention, keep athletes warm, keep everything covered. So when it comes to environmental stresses, we've got heat and cold are the two main things. And we have 3 levels of heat illness. So we've got heat cramps, heat exhaustion, heat stroke. Heat stroke is a medical emergency. That's what you hear of all the time when, like we read about the Jordan McNair case, different athletes unfortunately passing away due to heat illness. That is heat stroke. To prevent heat stroke, we want to rapidly cool them. We need to get their body temperature down because remember, they're cooking from the inside. So we need to get them cool as quickly as possible. The quickest way to do that is with a cold tub immersion. For cold, on the other spectrum, we have 2 levels. We've got frostbite and hypothermia. Hypothermia, remember, we want to rewarm the body, and frostbite, we want to rewarm as well. We want to slowly rewarm it unless it's a significant severe case, and then we need to rapidly warm them. And we want to use moist towels for that. And that is a medical emergency as well. Now, shock. Shock is something that can happen with any injury at any level. It doesn't matter what it is. It can happen at any level, any type, anything. It most oftenly happens with severe bleeding, fractures, or internal injuries, but it can happen at any point in time. It's what we call the progressive failure of body systems. And so there's all different types. There's 8 different types of shock, but it's the failure of different body systems. So in the inability of the circulatory system to provide adequate oxygen to the vital organs and tissues. And we go into shock to defend against this, to try to keep the oxygen for the vital organs and to keep it within the core organs that we need to survive. So the main types of shock, we've got hypovolemic, which stems from a trauma where there's blood loss. So it's significant blood loss, and it's a decreased blood pressure because of that, or blood volume because of blood loss. Respiratory shock, basically the lungs are unable to supply enough oxygen to circulate to the circulating blood. Traditionally, it's an injury to the lungs, like a pneumothorax or a breathing control mechanism. Neurogenic is typically the general dilation of blood vessels within the cardiovascular system. So typically there's about 6 liters of blood that can no longer fill the system because there's too much dilation of the blood vessels. And so they can no longer supply oxygen to the body because they've dilated too much, so it doesn't fill enough. Psychogenic, which is also commonly known as fainting or syncope, this is typically due to a panic or a temporary dilation of blood vessels that returns to normal, but because of that, it reduces the normal amount of blood to the brain. Cardiogenic, the inability of the heart to pump enough blood to the body. So cardio, we talk about the blood, and talk about the heart. Septic, this is due to severe infection, traditionally the bacterial infection. Anaphylactic results from a severe allergic reaction. And metabolic, severe illness that goes untreated. Example, diabetes or excessive loss of fluid, urination, vomiting, or diarrhea. So the chemical balance within the body changes. So those are the 8 different types of shock. So remember, we've got hypovolemic, respiratory, neurogenic, psychogenic, cardiogenic, septic, anaphylactic, and metabolic. So the last and final concern that we have is lightning. One of the top 3 causes of weather-related death is lightning. So we always need to be aware of it. We don't have a ton of it out here in Irvine, but we do have more of it in Irvine than other parts of Southern California because the mountain's right there. So you always need to have a lightning safety plan ready, and you need to designate people to monitor the weather, as well as knowing where to remove athletes to, and also watching the sky, because if you're the athletic trainer, you may not necessarily be watching the sky because you're watching the plays and watching the injuries happen. And so you may not notice what's happening with the weather. So you need to know where the nearest shelter is and how long it takes to get there. Also, how we measure lightning is called the flash to bang method. So it's estimating proximity of miles away the lightning is by counting the seconds between the flash of the lightning and the bang of the thunder. So, and then dividing that number by 5, and it gives you the miles away. For example, if it takes 5 seconds for you see the flash, you count 1 1000, 2 1000, 3 1000, 4 1000, 5 1000, and you hear the bang, that's and divide by 5, that means it's 1 mile away. So we at that point we need to be getting inside and getting inside very quickly. Now, when we talk about lightning safety protocols, we talk about the 30-30 rule. So basically, if the calculation is 30 seconds or less, meaning 6 miles or less, we need to seek shelter immediately. And if it's we don't resume outdoor activity until there's 30 minutes after the less audible thunder and lightning strike. So when we talk about a safe shelter, what is that? So it's a sturdy building or hard top vehicle inside. We don't need to stand under a tree. We don't need to stand under it. We need to get inside or in a hardtop vehicle. You want to avoid dugouts or sheds or picnic shelters if possible. It's kind of like trees. It attracts the lightning actually. So we want to make sure that we get to somewhere safe because you're going to be there for probably quite a while because you need to wait for that 30 minutes to make sure the storm has passed. Now, people are struck by lightning. So if a person's struck by lightning, you'll notice there will be burns at the point of entry and the point of exit, traditionally at the top of their body somewhere, and then at their feet. And they won't carry an electrical charge, so they won't shock anyone like the movies, like afterwards. They're not like got electricalness in them. It goes through their body. If you are stuck somewhere and you can't get to shelter and you realize the lightning is very close and is striking the ground, you want to get it in what's called the lightning safe position, which is a crouch on the ground with with your weight on the balls of your feet, with your feet together and your head lowered and your ears covered. Basically, you want to get as small as humanly possible and as close to the ground as possible. Is the ultimate goal. Now, people are killed by lightning as well as just injured by lightning. It happens, there's a lot of factors that it can happen to. We don't have a lot of lightning that actually strikes the ground here in Southern California, but we do have to take into consideration because you never know when it will change. I know in the Irvine area, most of the time our lightning is actually a horizontal lightning and it's a little bit higher up. But I don't know if you guys remember, but a few years ago, it was a Friday night football game night, and there was a huge lightning storm all in the area, and all of our games, we had to cancel our games because it ended up taking too long for the lightning storm to go away. So, recap. We need to know about heat illness, what it is, how to treat it, any type of cold illness or cold environment issues, what it is, how to treat it, 8 types of shock, and then the lightning protocols.